Hello, calculus students. Today, we will be learning the antiderivative or the indefinite integral of a function. This is defined by the integral of f of x dx. To understand some of this, we are going to need to look at the most basic and fundamental parts of the indefinite integral. The two most basic and some of the most important parts of the indefinite integral, or the antiderivative, is the integral of k dx and the integral of x to the nth power. Now these are the antiderivatives, so we're going to do the opposite of a derivative. Instead of taking away a constant, when a number is constant, instead of taking away and making it a 0, we're going to add. So this would be kx plus c. Now, the x was an added because it is the antiderivative. If we were to take the derivative of kx, we would just end up with k. And the c, this c, is a constant. A constant that is added because if we had taken the derivative of the original equation, any constant number would be made into 0, and therefore not factored into the antiderivative, or otherwise known as the indefinite integral. So we add a plus c to make up for that. X to the nth power turns into x to the nth power plus 1 divided by n plus 1. Instead of 1 being subtracted up here, it is being added, and instead of it being multiplied out into the front, it is being divided. Other than these two functions, we will also be learning everybody's favorite part of calculus, trigonometry. Yay! Now, let's look at some of these. As you can see, we have our constant on every single one of these answers. Do not forget to add the plus c if you see this indefinite integral. When it is an integral, you don't need the plus c. When it is an indefinite integral, do not forget the plus c. It is very important. You can get 1 point on the AP exam for just writing a plus c. Now, let us look at some examples. Here, I'll write the integral of 2x squared plus x minus 1 dx. The way that we would solve this would be using the fundamental equations that were shown earlier. If you can see, this 2x squared, instead of being a 2x squared, we will add 1 to the power, so it would be 2x cubed, and then we divide by the power. So it's 2x cubed over 3 plus x to the 1 power, because even though it does not have a power sign above it, it's still to the 1 power, would be x squared over the new power, which is 2, minus 1 times x, 1 being a number which would be k in the previous example, plus c, the constant. And you can simplify this to make it just look slightly neater. 2/3 x cubed plus 1/2 x squared minus 1x plus c. And this would be your answer. Let's look at another example. Let's do a nice trigonometry equation. The integral of 4x minus 3 sine of x dx would equal, well, let's see, 4x. To get the indefinite integral, we would do 4x, and because it's x, 1 plus 1 would equal 2, divided by 2, which is the new power, minus 3, we leave it outside, sine of x. Now, if we look back into our previous equations, we see that the indefinite integral of sine of x dx is equal to negative cosine of x dx. So we would replace this sine x with a negative cosine of x plus c. Do not forget this plus c, this constant. It is very important. Now let us simplify our answer to make it more neat. 4 divided by 2 would be 1/2. Excuse me, not 1/2. Sorry. Don't know what's wrong with my brain sometimes. 2x squared plus 3 cosine of x plus c.